So now we want to look at another type of differential equation. These are first order, and these are in a particular form. So you have to put the equation in that form. And then after you have put the equation in the particular form, you then have to find an integration factor. That's step part 2, where it says find an integration factor and use it to solve the differential equation. Okay, so first thing I want to start off is with the fundamental theorem of calculus part 1. All right, so the fundamental theorem of calculus part 1, I don't know if anybody remembers it. I usually teach, when I teach calculus 1, I teach the fundamental theorem of calculus part 2 first, and then I go back and teach the fundamental theorem of calculus part 1 because it's actually more difficult. Okay, it's the one where we have to remember that if I want to do the derivative with respect to x of the integral from a to x of f of t dt, it is just equal to it is just equal to f of t, f of x. I apologize. It is just equal to f of x. Okay, so we use that to solve some very difficult problems at the very end of calculus 1. Okay, so now let's suppose I have for a minute something that looks like this. I'm going to call it nu, and nu is a function of t. And let's say nu equals e to the integral of x of some f of tau, f of t dt. So I have something that looks like that. Okay, now notice that if I were to take the derivative of nu, so this is actually nu as a function of x, I apologize. So if I took the derivative of nu prime of x, it would be e to the integral of x, f of t dt, but then I'd have to multiply by the derivative of the exponent, and that would be the derivative with respect to x of the integral of something to x of f of t dt. And this is simply just going to give me, this part is going to give me f of x times e to the integral to x of f of t dt.
Professor.
Yes.
So is an integral in like an exponent?
The integral is indeed an exponent. Yes, yes, and yes. This integral is an exponent. Okay, so the integral is an exponent. All right, so now I want to just say, so suppose nu of x happen to be e to the integral of p of t dt. Then when I find nu prime of x, that's again going to be e, this is the exponent, p of t dt, but I'm going to multiply by the derivative of that exponent, and we now know the derivative of that exponent is just going to be p of x. Okay, so I want to use that, all right? So let's look at a differential equation. So we're going to look at a first order differential equation in standard form. Okay, so standard form is dy dx plus p of x times y of x is equal to q of x. So that is a differential equation in standard form. Okay, so here's an example. Dy dx plus 2xy is equal to 3x squared, the sine of x. Okay, so this is in standard form. Here you can see that p of x is 2x. It is the thing in front of the y. And you can see that q of x is 3x squared sine x. It is the only term on the right-hand side, and it does not contain y. Okay, another example, dy dx minus 4 over x times y is equal to cosine of x. All right, so now p of x is -4 over x. That is the thing that is in front of the y. And then q of x is just cosine of x. Okay, any questions about a differential equation that is first order in standard form? So if I have x, y prime plus 2y is equal to cosine of x, this is not in standard form. But I can put it in standard form by dividing by x. So now I have y prime plus 2 over x times y is equal to the cosine of x over x. And now this is in standard form, and I can see, here's my p of x. And that's my p of x. And my q of x is cosine of x over x. Okay, any questions about having a first order linear differential equation in standard form? It must look like the derivative plus p of x times y is equal to q of x. Okay, now let's just suppose for a moment I took and multiplied. I want to take and take the derivative with respect to x of y of x times e to the integral of p of t dt. All right, so I'm going to insert something. Okay, so let's consider for a moment this derivative. Okay, so I know you're saying, why in the world am I doing that? Well, we already talked about the fact that we know how to take the derivative of e to the integral of p of t with the x. We know how to do that. So this is a product rule. So as a product rule, I'm going to do the first, well, the derivative of first, which is y prime of x, times the second, which is e to the integral of x times p of t dt, plus the first, which is y of x, times the derivative of this thing. Now, we already said we know what the derivative of e to the integral of p of t dt is. Well, it's way back here. We said the derivative of e to the integral of p of t dt is just that integral times p of x. So I'm just going to get p of x times e to the integral of x, p of t dt. All right, so now I see that if I take the derivative of y times this thing, I'm calling this thing nu. Remember, I'm calling this nu of x. All right, so if I take the derivative of that, I just get y prime times nu plus nu plus y times nu prime. Okay, that's what I get. All right, so now what I want to do is I want to go back to my differential equation in standard form. So now let's go back. Dy dx plus p of x times y of x is equal to q of x. And I now want to multiply both sides by this e. Let's multiply both sides. So I'm going to get e to the integral of p of t dt. That integration goes to x, and I'm going to get dy dx plus p of x y. And let's multiply the other side. I'm going to get q of x times e to the integral of x of p of t dt. And now let's expand the first side. So on the first side, I get dy dx times e to the integral of p of t dt plus y of x times p of x times e to the integral of p of t dt is equal to q of x times e to the integral of x of p of t dt. Okay, I see something familiar. If you take a peek, this whole side right here is the exact same thing as what I have, right here. They're exactly the same. So that means that on the left-hand side, I can change my equation to be dy dx, I'm sorry, the derivative with respect to x of y of x times e to the integral of x times p of t dt is simply equal to q of x e to the integral of x of p of t dt. Okay, if I integrate both sides, so now I'm going to switch back to nu, just so you can see this. So remember, e to the integral of p of t dt is just nu. So I'm going to put nu in. So now I get d dx of y of x times nu of x is equal to q of x times nu of x. So now I'm going to integrate them. So when I integrate, I get y of x times nu of x. So I'm just integrating a derivative. And now I'm going to get the integral of q of t, nu of t, dt. And then I'm going to get a constant. And how nice is that? I now find that y of x is simply, if I integrate q and nu and add a constant and divide by nu, I have solved the problem. Okay. I'll give you a minute to finish writing that down, and I'm going to make some quick sense of it. Okay. All right, so here's the problem. Okay, so now we already know, here's how we solve the problem. So in order to solve the problem, the main thing is we have to find nu. We already know q, we already know y. What's in the problem? We have to find nu. All right, so here we go. First problem. dy dx plus y over x is equal to e to the x over x. Okay, any questions? That's the problem. All right. So now I can write this as dy dx. This is 1 over x times y is equal to e to the x over x. So now as I'm looking at this, what is p of, what is p? What is p?
1 over x.
1 over x. And what is q?
Would it be e to the x over x?
It's e to the x over x. Okay, so that right there is the beginning of the problem. You have now found p and q. Okay, now you must, so the first thing is identify p and q. You got that. The second part now is we need to find the integral of p of x dx. So let's just find this integral. So we take the integral of 1 over x dx, what do we get?
Logarithm of x.
The logarithm of x. Now, I don't need a plot plus c because when I multiply both sides, I'm going to get a constant, so I don't need the constant. So I'm just going to do a basic log of x. Okay, so now what is new? Well, it's e to the integral of that thing. So that's e to the natural log of x. Everybody see that? When you integrate, you get log of x. So new is just e to the log of x. Now simplify that for me. What is e to the log of x?
Is it X?
It's just x. Okay, so now I've done the hard part. The hard part is finding new. So now I know new of x is equal to x. All right. The next thing I need to find is the integral of p of x. I'm sorry, the integral of q of x times nu of x dx. Okay, so the integral of q of x, well, q of x was e to the x over x. Nu of x is just x dx. So this is the integral of e to the x dx. And what is that?
E to the x.
E to the x. All right. So now we get our answer. Y of x is equal to the integral of q of x times nu of x dx plus a constant divided by nu of x. So we get e to the x plus a constant divided by x. And that's our answer. Any questions about that? So y of x is equal to e to the x plus a constant over x. And that's why they told me in the beginning of the problem, which I forgot to write down, that x is positive. X can never be 0. Okay. All right, here we go. Next problem. X dy dx plus 2y is equal to 1 minus 1 over x. And again, they tell me x is positive. So x can't be 0. Okay, first thing I check, is it in standard form? Is the problem in standard form?
Yes.
So what does standard form look like?
Um, just from educated, I guess I thought that standard form was like y of x, or like y equals x plus whatever.
Okay, so here is standard form. dy dx plus p of xy is equal to q of x. That is standard form. Is this in standard form?
Do you have to move the X to the other side?
Well, I have to divide by x. So I gotta divide everything through by x. So I get dy dx plus 2 over x times y is equal to 1 over x minus 1 over x squared. So I divided through everything by x. Okay, any questions about that? Okay, I want you to write on your paper what P of X and Q of X are. So P of X is equal to, and Q of X is equal to. Identify your P and Q. Okay, so make sure your equation is in standard form. Number B, identify P of X and Q of X. So what are P of X and Q of X? P of X is,
2.
okay, who just answered?
2 over X.
Okay, 2 over X. It's the thing that's, remember, you gotta look at the standard form. It's the thing that's in front of the Y. Okay, so P of X is 2 over X. And what is Q of X?
1 over X minus 1x squared.
That's right. Okay, so now we know this is Q of X. Okay, I really want you guys to get these right on the exam because this is not a hard concept if you just follow the method. Okay, so now that we identified P of X and Q of X, now we need to compute the integral of P of X dx. So you get the integral of 2 over X dx. Well, that's 2 times the integral of 1 over X dx. So that's 2 times the natural log of X. Okay, any questions? Now we need to compute mu. Okay, so nu of X is e to the integral of that P. So it's e to the 2 times the natural log of X. Now that looks pretty nasty, but I can simplify that. Can somebody else simplify it? Can anybody else simplify it? What about the properties of logs? Remember the power law for logs?
That'd be 2x.
Okay, so I'm going to write it as e to the natural log of x squared, because the power law says I can take this 2 and make it a power of x. And then e to the log are inverse functions, so the only thing I get for nu is x squared. Okay. Now I need to compute the integral of p of q, always write p, the integral of q of x nu of x dx. Okay, so that's the integral. P is 1 minus 1 over x. Nu is x squared. I think this is wrong. It's 1 over x minus 1 over x squared. Times x squared dx. Oh, that's nice and easy. That's the integral of x minus 1 dx. And that turns out to be 1/2 x squared minus x plus a constant. All righty. Now my solution y of x is equal to the integral of q of x nu of x dx. You got to make sure you include that constant over nu. So I have an answer. So y of x is equal to 1/2 x squared minus x plus a constant over nu of x, which is x squared. So if I wanted to, I could write this as 1/2 minus 1 over x plus c over x squared. Okay. Any questions? Any questions? Okay, here's another one. We're getting the hang of it now. Okay, we're repeating the process. X, y prime minus y is equal to 2x natural log of x. All right, this time, no, yep. Okay. All right, so here's our problem. All right, is it in standard form?
No.
No. Okay, so let's put it in standard form. We're going to divide everything through by x. So we're going to get y prime minus 1 over xy is equal to 2 times the natural log of x. Because we divided everything through by x. Okay, any questions? Okay, what's p of x?
-1 over x.
Negative 1 over x. And q of x,
Would that be 2 ln x?
2 ln x. Good. Okay, next step. We have to, so now we need to find the integral of p of x dx. So that's the integral of negative 1 over x dx. We can pull that out and we get negative the integral of 1 over x dx. So that's negative the log of x. And so if you remember, I can write that as the log of x to the negative 1. Okay. So now nu of x is e to the integral of what I got. So that's e to the natural log of x to the negative 1. So that's just x to the negative 1. So that is 1 over x. Okay, so we found nu. Now we have to find the integral of q of x times nu of x dx. So that's the integral. Q of x was 2 times the natural log of x. And then nu of x says, oh, let's divide by x. So that's 1 over x dx. So this is the integral. So 2 times the integral of the natural log of x over x dx. How do I integrate that, guys? That's an easy one. I see a function and I see its derivative sitting right there.
Would that be with u substitution?
Yes. Okay, so we're going to do u substitution. What's u going to be?
X?
Okay, why would I make u x? Can you tell me why did you say x?
Because then it's gonna be dx, the derivative.
Okay, and what am I going to do with that whole log function?
So should we make the derivative ln x instead?
Oh, you're trying to do it by parts. I just want to do a regular simple u substitution. You're thinking too hard.
ln x.
Well, go ahead.
No, I said ln x for you.
Okay, so Maria, if we try to make u equal to x, all we're going to do is change our problem over to everything that just has u's. I need to make u something difficult so that I'm able to pull it out of the problem and put back in u that's something simple. So if we take u equal to the natural log of x, then what is du? Du is the derivative of that thing.
1 over x?
1 over x dx. So do you see my du right there? There's my du. So this is 2 times the integral of u du. So that's 2 times 1/2 u squared plus a constant. So I get simply the natural log of x quantity squared plus a constant. Okay, I'm done. Y is equal to the integral of q of x times nu of x dx Don't forget that constant. I need that thing over nu. So I get the natural log of x quantity squared plus c divided by 1 over x. Nu is 1 over x. So therefore I can multiply. So I get y of x is equal to x times the natural log of x quantity squared plus a constant. Okay. We are going to do one more, and this one we're going to have to solve for C. dy dx plus xy is equal to x. So dy dx plus xy is equal to x, y at 0 is equal to -6. Okay, so now that they have given me an initial condition, so whenever you're given an initial condition, you must solve for C. Okay, so is it in standard form? Is it in standard form? Oh, I should have saved this one for the test. This is a nice one. Is it in standard form?
Yeah.
Okay, so what is P of X?
Would that be just x?
X, and what is Q of X?
X as well?
X as well. Okay, so now I need to do the integral of P of X dx. So that's the integral of X dx. Nice and easy. I get 1/2 x squared. Okay, so now I can find nu. Nu of x is e to the 1/2 x squared. Okay, there's nothing I can do with that. It is what it is, just like it is. That's it. That's why I said I should have given you this one for the test, because this one is nice and simple. Okay, does everybody see that? I can't simplify it. It is, that's it. All right, so we're done almost. So now we need to do the integral of Q of X with nu of X dx. So that's the integral. Q of X was just X, and nu of X is e to the 1/2 x squared dx. So if I let u equal 1/2 x squared, du is x dx. So this becomes the integral. X dx is just du, and that becomes e to the u. What's the integral of e to the u?
E to
The
the U.
integral of e to the u.
E to the U.
E to the u. So I just get e to the 1/2 x squared. But here I have to include my constant. So y of x is just going to be e to the 1/2 x squared plus a constant divided by e to the 1/2 x squared. So now I have to solve for my constant. This is actually 1 plus a constant times e to the negative 1/2 x squared. That's what the solution really is. Okay, so there's y of x. Now they told me that y of 0 is -6. So I have to put -6 in for y, and I have to put in 0 for x. So I get -6 is equal to 1 plus c. So c is equal to -7. So now I've solved for c. Notice there's no more constants lurking because I had to solve for the constant. I get 1 minus 7 e to the 1/2 x squared. And that is the solution of the differential equation where I need to have to solve for the constant. Okay. Any questions? I've kind of done several examples. Do you guys, how do you want to proceed from here? You want one you work on by yourself, or you want some time to digest it? Hello.
I would like one to work on ourselves.
Okay. Ooh, mixture problems are hard. Oh boy. I like to do mixture problems, but not many students enjoy mixture problems. Okay, I'll give you one to work on yourself. Let's see. X dy dx equals cosine of x over x minus 2y. X is greater than 0. Okay. Okay, so we scroll up, and this is what your group told me. You said that you first moved the 2y to this side, then you told me you divided by x. So now you found p of x and q of x. You integrated p of x, and you got e to the log of x squared, and that just gives you x squared. And then you multiplied q of x by nu of x, and you just got cosine. You integrated cosine, you got sine. So now we know the integral of q nu. We put that here, we add plus c, we divide by nu, and we are done. Okay, any questions? Oh, that's not what I meant to do.